Dear students, welcome to our science episodes. Today we are going to discuss fundamental forces in nature. Did you ever wonder about forces causing some phenomena like lightning, thunder, magnetic attraction to iron, wind motion, earth pull by the gravity? Yes, forces. All these phenomena are the result of forces. Example of forces are gravitational force, electric force, magnetic force, kinetic force, and nuclear force. But what is force? Force is an attempt to change the object state from being static to motion or vice versa. So either the object is static and we are trying to move it, or the object is moving and we are trying to stop it, or attempts to change the motion direction. Look to this ball, the bouncing basketball. When it hits the ground, it changes its direction. This is force. So, force is a push or a pull to move an object or stop an object movement or changing the direction of a moving object. And force is measured in Newton. Look to this picture. Why does the book on the table stay still? Can you identify the forces acting on the book? This is the gravity pulling it down, and the push force of the table is trying to push the book upward. Therefore, the forces acting on the book are equal and opposite in direction. So these two forces are balanced. So the book will not ever move. In this case, why does the book on the table move? Simply because this boy or this man pushes the book with a push force. So a push force is applied on the book, and that's why the book falls down from the table. Look at this picture. If you push the wall by your hand, what will happen? I think nothing. Yes, the wall will not move because the force applied on the wall is not strong enough to move it. In a football match, what will happen when the attacker kicks the ball by his head? I think you guessed it right. The ball will move opposite to its direction of movement due to the kick-push force of the attacker's head. So this means that sometimes the force applied on the object causes the object to change the direction of motion. As a conclusion, an object at rest will remain at rest unless a net force acts on it. And if the object is in motion or moving, it will remain moving unless a net force acts on it or stop it. Forces acting on an object will cause the object to move or change the direction of movement as well. Here are some fundamental forces in nature. We're going to study gravitational force, electromagnetic force, and nuclear force. The first one is gravitational force. And let's think about this activity together. Earth attracts objects. Have a set of objects that differ in mass. Let's say 1 kilogram, 5 kilograms, and 10 kilograms. Try to lift each mass and put it on the table. Start with the smallest mass, then the next in order, until the biggest one. What do you find? The exerted work to lift an object increases when the object mass becomes greater. I think it makes sense. Whenever the object mass becomes greater, so you need more work to lift it up. And the conclusion is, Earth attracts objects toward its center by a force known as weight. So weight measures the attraction, the force of gravity of Earth that attracts the objects towards its center. And this force increases when the object's mass increases. Look at this boy. He's holding a tennis ball and a feather. What do you think? Which one has more weight? Of course, the tennis ball. So the tennis ball will be attracted to Earth with a force bigger than the force needed to attract a feather with very light mass. So let's talk about weight. Weight is not mass. Mass is the amount of matter in an object. But weight is the force of attraction or the pull force of attraction of Earth. An object's weight measures the Earth's ability to attract the object. We call it gravity. And it is measured in Newton. Weight is another word for the force of gravity. We took before that forces are measured in Newton and weight is a force. Therefore, the unit of measurement of weight is also Newton. This point is the object's effective point, the center of the object's center of gravity. We can calculate weight by multiplying the object mass with Earth's gravitational acceleration. The Earth's gravitational acceleration, with the symbol g, is approximately equals to 9.8 meters per second square. From the above equation, we can conclude that if we want to calculate mass, it's weight divided by the Earth's gravitational acceleration. Again, weight is measured in Newton because it's a force. Mass is measured in kilograms, and the Earth's gravitational acceleration is measured in meter per second square. Here is the equation. Can you give reason why your weight on Earth is more than your mass? Let's see together. Look at this picture. This man weighs on Earth 784 newtons, while its mass is 80 kilograms. Why the weight is more than his mass? Simply because weight is the product of mass and Earth gravitational acceleration. They are not equal. Weight is more than mass. Can you calculate the weight of an object? Its mass equals to 30 kilograms. Knowing that the Earth's gravitational acceleration equals 9.8 meters per second square, according to the equation, weight equal mass times gravitational acceleration. So weight will be equal to 30 times 9.8, which is equal to 294 Newton. Now, can you calculate the mass of an object? Its weight equal 50 Newton. Knowing that the Earth's gravitational acceleration is equal to 9.8 meters per second square? Yes, of course. We know that mass equal weight divided by gravitational acceleration. So mass will be equal to 50 divided by 9.8, which is equal to 5.1 kilograms. What is meant by the Earth force of gravity acting on an object is equal to 50 Newton? we will do the opposite. This means that the object's weight on Earth is equal to 50 Newton. Now, does the mass of an object change? Of course, no. It doesn't change because, as I said before, mass is the amount of matter inside an object. And this amount of matter will not change even if the object changes its place. Here is another question. Does the weight of an object change? From this equation, we will know that weight depends on the mass of the object, which of course will not change, and the gravitational acceleration, which changes. And since the gravitational acceleration will change, so weight can change. The gravitational acceleration value varies from one place to another on Earth, and it decreases as the distance from the center of Earth increases. This means increase in altitude or height. So whenever we go far from the center of Earth, the gravitational acceleration will decrease, and therefore the weight also will decrease. Now it's time for questions. Calculate the weight of an object. Its mass is 200 grams, knowing that the Earth's gravitational acceleration is equal to 9.8 meters per second square. Now the mass is in grams, so we have to change it to kilograms first. So we will divide 200 by 1000, which will give 0.2 kilograms. The weight equal mass times gravitational acceleration. Therefore, 0.2 times 9.8 will give 1.96 Newton. Now choose the right answer. Earth's gravitational acceleration changes from one place to another on Earth's surface due to the object mass, Earth mass, distance from Earth center, or temperature. It is the distance from Earth center. Thank you. Dear students, thank you for watching and see you later in other science episodes.